All right, everybody, you can call this class 107 if you'd like, but what you're going to be working on today is working through this entire homework packet, similar to one we've seen before. There are 22 questions. Most of these you've actually already answered in the Google Forms you've been filling out. All the work is here, or excuse me, not all the work is there, but all the answers are there for you at the end where they usually are. Okay, your job is to work on this packet, show work for every single question. This packet's pretty long. It's like 7 pages long. I don't recommend you print it out. If you got to print it out, I would recommend you use a format where maybe you're printing 2 pages on 1 page of paper. For example, you can like print page 1 and 2 side by side. That way you can actually fit 4 pages on one sheet of paper. That way you could save a little paper. What I'm going to do is I'm going to have you upload this with all the work shown, explanations for each one. You're going to upload it to a Google form just like you've been doing. Then I'm going to pick 2 questions to grade, and that's it. If you did those 2 well, you showed work, you'll get full credit. If you don't do those 2 well, you're not going to get full credit. All right? So, again, most of these you've seen. One I want to go over, though, with you is numbers 5 and 6. They look like questions. You might think, I have no idea how to do this. But these questions are actually questions we've seen before. Okay, and we can use methods we've seen already to solve them. Okay, all the way back from the first quarter. So number 5 says, base your answer to this question on the information and diagram below and your knowledge of physics. The diagram shows a negatively charged oil drop. So why don't we just draw that in on that oil drop? Just put a little negative sign on it. That is suspended motionless between 2 oppositely charged parallel horizontal metal plates. That kind of makes sense, right? Because gravity's pulling it down, but since it's negative, the positive is pulling it up, the positive plate's pulling it up, and the negative plate's repelling it upward. The electric field strength, we're going to go over electric field next unit. The electric field strength between the 2 charged plates is 4 times 10 to the 4th newtons per coulomb. You don't need that to answer this problem. The 1.96 times 10 to the negative 15 kilogram oil drop is being acted upon by a gravitational force, Fg, and an electrical force, Fe. So number 5 says, calculate the magnitude of the gravitational force acting on the oil drop. Show all work, including equation and substitution with the units. So let's look at our Fg equation. So there's actually 2 of them. The first one is Fg equals g m1 m2 over r squared. That's the universal law of gravitation, not one you need to use here. When something's near Earth's surface, you can use the one below it. G equals Fg over m, which I just write as Fg equals mg. Hopefully you remember that. So if we start with Fg equals mg, okay, remember Fg is weight. Maybe I'll write that down. Fg is weight and force of gravity. So Fg equals, now m is 1.96 times 10 to the negative 15 kilograms. G is 9.8 meters per second squared. And throw that in your calculator. You should get a force of 1.92 times 10 to the negative 14. Remember, all forces are measured in newtons. Okay, so we actually didn't have to use any of the new stuff we've learned. That's going back to one of the first units. I think it was unit 4 maybe. Now 6 says, determine the magnitude of the upward electrical force acting on the oil drop suspended motionless between the charged plates. Well, let's think for a second. It says it's suspended motionless. It is not moving, it's not going to move, it's just stationary. So A is equal to 0. Therefore, the net force is equal to 0. Okay. That means that all the forces acting on it must be equal to 0. So that means that FE plus FG equals 0. Okay. Well, let's look here. They drew a free body diagram for us. FE is pointing upwards, so we'll call that positive. FG is pointing downward, we'll call that negative. We already found the magnitude of FG, we just have to tag a negative on the front of it. So FE plus negative, sorry, it's glitching on me for a second, plus a negative 1.92 times 10 to the negative 14 equals 0. Just one sec, it's freezing up on me again. Just going to close the app and open it back up. Therefore, the electrostatic force is equal to 1.92 times 10 to the negative 14 newtons. And that would be your answer there. So some people, so that's like the technical way to do this one, the correct way to do it. Some people, though, they would just say, well, if F net equals 0, all the forces must cancel out. Okay, so you also notice here that you might not have enough room to show all your work if you print out this piece of paper. So I would highly recommend maybe just doing this all on a separate piece of paper, numbering each one and making sure you have enough room. All right?